Hi everybody. Is the microphone working? Yes. Thanks for coming today. My name's Craig Lawton. I'm a Solutions Architect Manager based in Melbourne, Australia. Australia is a very big country and our universities are very big as well. So today we have our top-ranked university, University of Melbourne, here to talk about their Smart Campus, which I'm really excited about. The campus, the Smart Campus platform was built over 4 years and covers 50,000 students. So the campus really is a small city. When we think about transformation, we think about digital transformation, we think about how we can improve citizen experience and how we can improve student experience, how we can make better decisions quicker, and also how we can respond to the unexpected. And you'll hear a little bit about how the University of Melbourne responded to the pandemic, for example. There's also a very subtle and nuanced element to inclusion and accessibility when you're looking at smart cities or smart campus solution. And that is when you make a decision to choose an open platform and open data standards, it really allows builders and innovators and researchers, in the case of the university, to come on board the platform and improve it. And there's also, when we talk about open data standards, we're going to look at some of the open data standards that AWS has chosen and also the university. The NGSI information model, which is used in our smart territory framework. And then the university have looked at OGC for geospatial use cases and data, and the haystack standard for building management. And how important that is in creating a platform that is interoperable, can be trusted and extended and built on as you move forward, but also respects privacy and security concerns. We're going to show a range of architectures today as well that support the elderly, the immunocompromised, visually impaired, rural populations, and also mental health impacts and more. And then sprinkled through the conversation, you'll hear a lot about our partner network. AWS has hundreds of thousands of partners, and specifically in smart cities and smart campus, the collaboration is key. It really does take a village to create a smart city. Now, a few years ago, I think 4 years ago, I started looking at the smart cities arena, and what I did was I went out into a lot of events to shake hands and meet people and meet innovators who were building solutions. They might have been building solutions around water management, energy management, transport, waste, all of these domains. And inevitably, they were using cloud computing, and many of them were using AWS, and yet there was this feeling that they were all isolated solutions. And if you look at the diagram, you can see the pink solutions. This is what I was seeing in the market. But then I'd go speak to local governments, or I'd speak to facilities managers, people responsible for places, and they really wanted data and insights. And so there was this desire to create a platform and bring all these disparate solutions together. So how do you resolve this? Well, starting with the solutions side, we launched the AWS Smart Cities competency this year. And so this is built on the realisation that there were a lot of people building solutions, and we wanted to validate those solutions, make sure they met the high bar of a competency, and then we could promote these solutions for the partner network and technology providers globally so they could grow their businesses. But then importantly, local governments and customers could find these solutions that we've validated and deploy them into their networks. And an example of this is a company called Place Intelligence. They are founded by a former member of the City of Melbourne, and they've grown a global business, and they've done some work for Campbelltown City Council. And their platform is about location insights. And this is a common use case where people are wanting to understand what's happening in a space so that they can justify investments and also measure the return on existing investments. And so one of these solutions providers that are going to be in our Smart Cities competency, I believe, very soon. And if we look at the elements of all these solutions, all these silos, you might have waste and light management and all these different ones here. They have common elements. And if we start at the bottom layer there, we can see there's an ingestion layer. And that might be IoT sensors, mobile data, many different kinds of ingestion data. If we look at the middle tier, that's where you organise and manage that data, provide security, store it in the right data store, whether it's hot, cold, warm. And the top tier is where you're looking for insights into that data. So this is a common application stack, if you like, for these different solution providers. But what customers are after is they wanted to bring this together into a single platform. And the challenge was, how do you make it suit existing solutions, but also future ones, which we don't know are going to be, what's going to be invented. And whether they're partners or competitors, how did we make sure that we had this interoperable approach in mind as we went for each new source of data? Otherwise, you'd need to adjust this platform every time you added a new solution. And that would create tech debt and therefore reduce the effectiveness of the platform as you went forward. And when you're thinking about this platform, we always think about smart data, and I mentioned that up front. And so AWS is part of the Smart Data Models Consortium. It's built on the NGSI information model, and it provides 700 data models in 12 different domains, and you can see some of the bottom there. So when you're using our platform, which I'll show you in a sec, you know that you're using open data standards, which then facilitates that ongoing use of the platform. And then a common smart cities platform, just to give the high-level overview so you can see how this pattern gets repeated. It's very common to many modern data architectures. You've got producers, IoT sensors, legacy systems and solutions coming into a core platform where you have data standards, both around the data models, but also the methods of access, security and governance. And then on the consumer side, you have the intelligence, the citizen-facing systems, etc. And at AWS, we've developed this smart territory framework, which is an implementation of this, if you like, and it's open source. The GitHub link is down the bottom right there. And this was to overcome this challenge of interoperability and build something that was future-proof, but it was flexible enough so that you could have a range of inputs or producers of data coming into a common platform, STF core, where the data was in a predictable standardised fashion, and then you could have consumers of that data on the other side as well. And when we're successful with a smart cities platform, it allows us to make better decisions faster, it allows us to respond to the unexpected, better citizen experience, uncover opportunities, and improve efficiency, which is great for taxpayers as well. Now, to go through a few high-level architectures and solutions that we've seen through our network, I'm going to introduce Mai Nishitani, who's going to talk about some of the great work that IDEA11 has done.
All right, thanks, Craig. My name is Mai Nishitani. I'm a solutions architect from Amazon Web Services, and I used to be a customer of Craig's. And I just like to ask the audience, who's been flooded in before? Or knows someone that's been flooded in? Awesome. Oh, it's not awesome, actually. It happens quite a bit. It's been happening quite regularly all around the globe, especially in Australia. Now, what about parking? Has anyone had to find some street parking and had to pay, obviously, money to park? Anyone? Yeah, a lot of people. Yeah, so these are two problems, or daily activities, or not activities, or issues that citizens face every day. Hopefully not every day. So what would happen if a city council had to make those decisions around how to evacuate folks as quickly as possible? So being proactive about evacuating citizens so they don't get flooded in. So one of the AWS consulting partners, IDEA11, worked with this particular city in Australia to facilitate this with technology. I know Craig mentioned using technology to actually make these potential emergencies and disasters more efficient. So IDEA11 is an AWS consulting partner who've won many awards, and their name IDEA11 actually derives from the 11th idea on the whiteboard in collaboration with the customer is often the best solution to kickstart the project. So what IDEA11 did with this particular city in Australia was to implement the flood emergency support system. So what that involves is water engineers from the city work together with IDEA11 to develop this flood app, which actually involves some heavy computations on a server that was actually underneath the water engineer's desk. And obviously you can imagine the amount of cost involved in not only the hardware, but the operational maintenance of that. And obviously the amount of data that they needed to retrieve, both hopefully in real time, and then they can calculate really quickly. So if you can imagine all the catchments across this city and calculating computationally where that water level or flood level might be for each of the areas, it actually took 8 hours. So what they were able to do with ID11 was come up with a solution that reduced it down to 3 hours, which is awesome. Now, what what solution did they come up with? They used AWS Lambda, AWS Step Functions, and Amazon EC2 instances. Instead of having these servers underneath people's desks, they were able to calculate these flood levels quite quickly. So that was a win for both the city and the citizens. So what about the parking projects? So if you can imagine, as a tourist, you want to spend up all your currency, right? Especially if you come from a foreign country, like even in Vegas, if I was driving and if I needed to find street parking, I want to use up all my coins, especially. So in the city, it is a very touristy area. So what happens was the city council staff would roam around in their vans, collecting all the coins from each of the parking meters across the city. And you can imagine it will take more than 2 to 3 hours just to go to each and every parking meter. It's not efficient at all. So what did they come up with? Once again, the answer is data. So with data, they were able to collect real-time data from these parking meters and be able to route their staff across the parking meters that actually had their till that was full with coins. So that way, the parking meter staff can actually focus on some innovative work. And how did they do that? They used Amazon Kinesis for data collection, real-time data collection. They stored that data in Amazon S3, and they used Tableau for their business intelligence tool to see that graphically. So it was not only a win for the city council staff, but it was a win for the citizens because with that data, they could determine which areas were busy and be able to create more parking spots for the citizens. All right, let's move on. All right. So, can anyone guess what spurred on digital transformation across organisations? I know it was all over LinkedIn. Yes, COVID. So now, aside from digital transformations for organisation, which was a positive effect overall, for individuals, especially during lockdown, it was a very isolated time. So how did they deal with that? It led to a lot of vulnerable people that were unable to access resources. So let's talk about Hello Sunday Morning. So Hello Sunday Morning is an organisation that helps people change their relationship with alcohol. They launched the Daybreak app in 2016, which is a community of like-minded people posting about their sobriety journeys and alcohol consumption habits. They offer 24/7 mobile support, and they post about sobriety journeys and one-on-one sessions with health coaches as well. Now, previously, prior to COVID, Hello Sunday Morning and the Daybreak app had 80,000 downloads with 7,000 monthly active users, which is still impressive. But when the COVID lockdowns came around, they had a spike in usage with all these vulnerable groups of people trying to get sober, right? So there was a spike in increase of up to 25%. And how do they deal with this spike? Well, the answer is with AWS. They were able to increase the capacity and be able to scale out without having to increase their costs as well. Now, with lockdowns, you can imagine that this community could not meet in person. So that's where this app was very useful to be inclusive across all citizens. Now, with this success, the Australian government was able to fund them with a further 1.5 million Australian dollars, which is very impressive. Now, what does the future hold in terms of Hello Sunday Morning? Now, they intend to integrate some data and analytics to collect some data from these users, so new users can actually create their own custom sobriety journey via the app. What else is in store? So you can think about artificial intelligence and machine learning. So what they plan to do is stage any medical interventions by medical professionals if they pick up any posts that they think that might require some intervention there. So let's talk about mental health. I know that's been quite a bit of focus around there, especially around COVID and beyond. So We Care Community Services is located in Singapore, and they offer essential health support. And they also had a spike in therapy sessions, up 900 hours from pre-COVID to during and after COVID. So once again, how do they deal with that spike, right? Previously, they used to have an on-site call centre. Now with lockdowns, they still wanted to continue to operate, so what they did was to move that into a total end-to-end digital call centre with Amazon Connect. And with that, they were able to offer more work for the remote staff, as well as users that required mental health support in remote locations. So they've changed their entire business model due to this particular innovation. So let's talk about accessibility for citizens in smart cities. So talking about remote users and people located in remote locations. So dealing with remote communities can be challenging, right? And you can imagine the global rural population is now at 3.4 billion and beyond. And 90% of them live in Asia and Africa. So there's this company called Geospatial. They're located in India, and they're working with the government and healthcare facilities to help elderly people and pregnant women. And they have this personalised and predictive healthcare app called SaveMum. And what that uses is wearables for reducing mortality and maternal issues. So the doctor can stay close to the patient, even though the patient is thousands of kilometres away. So how does that technology work? They actually have a wearable that monitors patient vitals and also stores patient data. And the cool thing about it is that they use a medical device called an allotricorder, which is used in remote areas with little or no connectivity. Once it gets connectivity to the cloud, it transmits data. From the AWS side, it uses Route 53, which is our DNS service, alongside their web application and wearables. And let's talk about the city of Sabai in Japan. This is a whole city that is looking out for their citizens. What they are doing is using open data on AWS for collecting data around its population, the temperature, around their disaster shelters, and around parking. We talked about that, and wheelchair access as well. So this data collected is open to the citizens, and it's not just a one-way street. The citizens themselves can contribute to this open data platform on AWS. And how do they do that? They do that, for example, if a person finds a pothole in a road, they can take a picture of it, upload it to the mobile app, and then the city staff gets it and they can go ahead and remediate that issue. So it's definitely a bi-directional approach of data sharing. All right, up next I will hand over to Jason.
Hi everyone, thanks Mike. Some really great use cases you can see leveraging Amazon technology. So my name's Jason McKay, I'm the Director of Strategy, Innovation Assurance at the University of Melbourne. And I've been privileged to lead the Smart Campus platform for the last 4 years. So before we get into that, I wouldn't mind talking a little bit about the University of Melbourne itself. And so we're quite proud to be ranked #1 university in Australia and number 34 worldwide. We support over 54,000 students, of which 40% are international from over 150 different countries. We also support around 12,000 academic and professional staff. Our campuses are located across 7 locations in Victoria, Australia, with our main campus, Parkville, being located in the northern part of Melbourne CBD, which is essentially a small city within itself, with all the major services you could imagine. Across those 7 campuses, we support over 500 buildings, and all the buildings are different ages. Some have heritage overlay, different sizes, different mechanical plants, and as you can imagine, at scale, it's really hard to manage and maintain those particular buildings. So, how did we kind of come about this whole Smart Campus initiative? And like any good story, I was invited to the pub to have a conversation with my boss and the head of facilities, the CIO. And they were kind of describing an issue, which was, we've got all this data, some of it's locked in with our vendors, they charge us to get the information back. We've got a lot of other data we've got access to, but it's in disparate systems. And so they really were saying it's hard to answer questions when people say, how is our estate performing? How are our services performing? And so for want of a better term, they were describing essentially a single pane of glass where they could start to see how our operations are, create interventions, improve the service levels across those 500 buildings. So I jumped at the chance, not really knowing if we could do it or not, to be honest. Universities, we're not very good at building in the cloud at this point. We didn't have a lot of capability, but I was pretty confident using some technologies, cloud technologies, we could start to get here. And from there, our Smart Campus initiative was born. So basically, we truly were starting with a clean slate. We needed to find a cloud platform, and we partnered with AWS. And they've been a fantastic partner through this journey and continue to support us through our Smart Campus initiative and through other initiatives around the university. We wanted to set up a sensor network, and so we settled on LoRaWAN, and our partners Mesh really helped us out in acquiring, maintaining, configuring, and today support us with our sensor rollout today. We didn't have the skills in-house. Like I said before, we hadn't really built on top of cloud platforms, and so we partnered with Dias to help us build out our landing zone and really give us some good insight into how to run and operate and optimize in building applications on the cloud. And finally, we needed to visualize what we had, and we're already using Splunk for our operational intelligence and our SOC and SIEM, and we're using maze maps for our wayfinding app for our students. So year 1 was very foundational, and we took an interesting approach in building it from the data lake up. It was focused on getting data classification, data standard security built in. We talked to a lot of different universities and different organisations, and a lot of them led with use case first. And what we found is when they actually brought more use cases on, they were really getting stuck in trying to get the data right. And so we focused in building out the data lake. We set up our LoRa network, got our gateways up and running, and we started playing with different sensor technologies, and some worked, some were a complete fail, I'll be honest. But really just trying to understand, how do we communicate with these? What's going to work in the long term? You know, battery life, connectivity, how do we make all that work? And so it was a really good year, but not a lot of output. Year 2, we started to scale. We started to set our patterns, get our standards, start to roll out our sensor fleet, the ones that we'd settled on, and really start to drive some insights around the campus. And then COVID hit. And it was a really interesting time for us. We decided to pivot the platform. It provided a bit of a unique opportunity that our pandemic response team really needed data around occupancy around the campus and how our buildings are kind of performing. So one thing about universities, we're either really good at being completely open or completely closed. And now we're finding ourselves with some of the strictest lockdown laws in the world in Victoria, having a half-open campus wasn't something that we're particularly good at. So how do we provide that data, and how do we support our operations team and our pandemic reset team in supporting that? So it was a great learning for us, but it wasn't something that was going to take us into the long term or the future. So years 3 and 4, we've really learnt a lot about what it means to have a safe and inclusive campus. It's led to a lot of extra funding to roll out occupancy sensors and CO2 sensors, and really gave us great insight. We started to see a lot of traction and people getting on board and using it as an operational platform around the campus. And as we move into year 5, I'm kind of proud to say that we're closing down the program and it's becoming an OPEX-funded core capability of the university, which I think is fantastic. Ooh. So we've kind of got 4 focus areas, and Mark's done a really great job in setting up the product strategy around those. So we really do focus on campus operations, so how we maintain our spaces and assets, and how we provide alerts for intervention from some of our staff to actually change the way that we operate the campus. The estate planning, how we use our spaces, how we configure them. Do we input into master planning for long-term future plans for building new buildings, or do we have enough space to basically leverage what we have? The campus experience, so really a focus on inclusivity, making it safe and comfortable for students to learn in and staff to feel safe to come to campus and work in as well. And then we really aim from a sustainability point of view to understand our impact and our footprint and provide data that can help our sustainability teams understand how their interventions are improving that. So as I said, we focus foundationally on our core, which essentially is an AWS data lake. It leverages over 10 plus different Amazon services to pull that together. And we take a lot of inputs. So we take inputs around occupancy. We do this via fixed cameras above different spaces. We use LoRa sensors to do that. CMX data from our Wi-Fi network, and also information from our AV, which is Crestron Flex, to bring that in, understand how spaces are being utilised. We've predominantly got most of our building management solutions onboarded to the system as well. We look at space comfort through temperature, and whether that be humidity, and CO2 sensors rolling out. We've put out, I think, about 2,500 sensors to understand what is the air mix, how is the air quality in that particular space. We've also been hooking up all our utilities, so energy, water, looking at doing gas pretty soon as well, just to understand how that's getting utilised and how much are we consuming across all our different operations and locations. And of course, to contextualise that, we need our enterprise reference data. So we're bringing in, whether it be class scheduling data to overlay on occupancy, or whether it be our building standards and naming conventions, if you like. So on the opposite side, we have all the outputs. So what we've been doing in that space is really looking at safety and well-being. So during the pandemic, it could have been around contact tracing. We created a QR code app to actually understand who's going into spaces to enable that as well. And then also providing a nice, comfortable, safe place to live and learn. Estate performance and efficiency. So we provide data to talk about how buildings are performing, whether at the building, the floor, all the way down to the room level in some instances, and then inputs to our future state master planning as well. And then information to support building operations, whether it be optimisation models, alerting. So hopefully all of that is leading to what is more a sustainable campus, all the inputs that we can use to improve that. One of the interesting byproducts we've had while rolling out this particular platform is that it's become a living lab or a learning platform that we can provide to our teaching staff so students can learn from it, understand how interventions make a difference, and rich data sets that our research community can use for research purposes. So, As we kind of touched on the last slide, we do support a wide variety of users, and some of them directly and some of them indirectly. And so students, particularly around having a comfortable space to learn from and a living lab to learn from. Our academic teaching, whether it be inputs into class scheduling or once again, a platform to teach from. Our academic researchers, rich data sets, sensor platforms that they can use to understand and perform research. On the other side, we have our campus operations, and we provide real-time alerting and reporting and automation of services to improve the way our services are delivered across our campus. Office of the COO and CFO, really to try and understand how well our services are performing, which services should they invest in, and then input into what is our future state master planning. And interestingly, a lot of external third parties across the university, so a lot of maintenance contractors who can use the platform now to understand issues and alerts as they arise and potentially not have to attend campus sometimes at a cost to us or a cost to them, so reducing the overall impact across our service landscape. So how do we visualise this? Mark will go into this in a lot more detail, but we kind of have two visualisations. One is a near real-time digital twin on the left, which is our Campus Now application, and really providing operations with a way of looking across our campus all the way down to a room level around how space is performing, particular alerts, environmental alerts that might be required to support, and the mix of air and quality and temperature and CO2. And on the right-hand side, we've been utilising Splunk to build out some analytical dashboards to provide long-term trending forecasting and insights into our energy use across the campus as well. So I'd like to now hand over to Mark, who's going to take you, I guess, through a lot more detail of what we just touched on then. And I want to thank AWS again for the opportunity to speak today, and we'll see you soon.
Good afternoon, everyone. I'm Mark Morris. I am the Product Manager for Smart Campus at the University of Melbourne, and it's fantastic to be here today, and I'm very grateful for you all to come along and have a listen to what we have to say, and I'm very excited to be able to talk about some of the very interesting things that we've been doing with our Smart Campus platform at the university. But before I do that, though, I'm going to give you all something to ponder. I'm going to ask you, if you were to sit and think about what is the most effective way to advance an individual, a community, or a society, what do you think that might be? Or what do you think that might look like? And for me, I believe that it is open, equitable, and inclusive access to both knowledge and information. And so within the Smart Campus platform, as Jason spoke to, it does have a very operational focus, but one of the tenets that I am really interested in is ensuring that what we collect and the capabilities that we build are available to our university community to enhance their research or enhance their teaching and learning. And I hope by taking you through some of these cases today, I'll be able to demonstrate that we are actually able to do that. So the first use case I'm going to talk about today is estate planning. So as Jason said, we have a very big campus. It is essentially its own suburb. It has its own zip code, and there's around 500 buildings in the estate. So a very big thing to look after. And one of the things that we're very keen on is understanding whether or not those spaces in those buildings are meeting the needs of our students. And so what we did was we embarked on a project with 4 key components to begin to understand these different spaces and how they were being used and who they were being used for. And so we started with the sensor fleet. So we've rolled out sensors to both quantify occupancy in individual rooms as well as occupancy at both the floor and building level. We've built a number of system integrations with things like Archibus and our scheduling tools, so we can understand information about that space. Is it a teaching learning space? Is it a lecture theatre? Is it a breakout room? Is it tiered? Is it not? And then what class is on in that room at that time? How many people are supposed to be in that class? So we take all that data and we contextualise it, and then we're able to produce some very interesting reporting. And if you want to know a little bit more about the sensors, so we've got the Steinel room-based sensor, so that is a sensor that counts people in the room, and the Zovus sensors, which quantify people moving through exit points and be able to give you a view of what's happening at any point in time in that space. So this is our Campus Now application. It shows a real-time view of a particular space. We've developed some forecasting or some busy time models on various important spaces on the campus, so we can provide students with a view. I need to go to the Eastern Resource Library this afternoon. How busy is it? Oh, it's pretty busy. I think I'll put it off and I'll go maybe in the evening. So try and communicate to the students, how busy the campus is. And this is sort of one of my favourite graphs. So this is some of the work that we do from the different data points. So the very top line up here, which you can't see the cursor. Okay. So the very top line in the dark orange, that's the actual capacity, the planned capacity. So this room has a capacity of 530. It's a very big lecture theatre in the university. And we can see there that the planned capacity for that room actually exceeds the physical capacity. So what we do at the university is we have a planned capacity is where we're going to run a subject in a room and we think, okay, well, I think we'll probably get X number of people registered for this subject. So already we've highlighted a problem that we need to take back to our timetabling people and say there's a mismatch between your planned and your actual capacity. If we then look at the area of the chart below the purple there, so the purple vertical lines denote that there's a subject running in this space between 1 and 2:15 p.m. And we can see that the planned registration size for that room was 20, but in actual fact we got closer to 15 people registered. So, oh sorry, that's the wrong side. On the other side, on the right-hand side, we can see, I can't really see it, hang on, the 350, and then 320, and then we actually got around 100 registered for that subject. So again, there's a mismatch between the planned registration and the actual registration, and so highlighting that this room's inappropriate for this particular class. And then if we drill down one more level, we can see down the bottom, that is the actual people who physically turned up to that subject at that time. And you can see it's well below the number of people that actually registered for that class. So we are actually working now also to integrate into this chart the participation level for our online people. So we have the full view of both physical and online viewing. But you can see here that it's very telling that there's a problem with this particular subject and its participation. So it allows us to then go and draw other sources of information from different parts of the university around, say, our learning management system, our timetabling system, and begin to ask the questions as to why is this space so poorly frequented by the students. So again, as I said, the benefits of this is that we are able to improve the efficiencies of our spaces and use them to their maximum efficiency. We can begin to ask and answer questions around, are these spaces meeting the needs of our diverse community of students? We can also use the data for data-driven maintenance schedules, so ensuring that the spaces are always clean and well maintained and feel safe. And then finally, we can also use the data to inform business cases. So if we're contemplating building a $500 million new building, does the data really suggest that that's a good idea? Is that a good use of our money? Now I'm going to talk a little bit about COVID. Because, as Jason said, COVID fundamentally changed the way we all worked and lived and played. And the university was certainly no exception, and we were closed for an extended period of time. And when the government allowed us to bring the students back, first and foremost in our mind was ensuring that we provided a safe campus for them to come back to, but that they felt it was safe to come back to. And so there was two initiatives that we worked on. One, as we've talked about, we produced a contact tracing application to allow us to undertake contact tracing through the university well before the Victorian government rolled out their contact tracing application. There was a QR code-based application. We ingested a lot of data into the data lake, and we were able to produce weekly reports for our public health network team, and also be able to respond to any positive COVID cases on campus and ensure that anybody affected was contacted in the requisite amount of time. And so we were able to demonstrate through this process that we had a strong handle on contact tracing within the university and give the students confidence from that perspective, things are in hand. The other thing we did was we installed a significant number of CO2 sensors across the university, and we did that to use CO2 levels in a classroom as a proxy to air quality and more importantly, the turnover of air in the classroom. Because really what we wanted to do was be able to demonstrate that we were getting the requisite amount of air turnover in those rooms to minimise the ability for airborne pathogens to move between people, such as COVID. And it was a really interesting project because it was done collaboratively. So we had our Smart Campus team who did a lot of the technical work. We worked with our campus management team who do a lot of the facilities work to understand more about air handling units and dampeners and different things around air, which was completely foreign to us all. And then we also engaged with our university academics to say, okay, well, there are some experts in this field, what is a good amount of air turnover? How should we be operating these rooms to minimise the chances of pathogens moving between people? And the result was, as I said, the reporting to our health network, but also reports that went to our campus management team to say, okay, well, this room's been identified as being out of or above the threshold. You need to go and intervene, immediately to get that air turnover going again. So again, we facilitated this through the sensors. These were done with LoRaWAN. So LoRaWAN has demonstrated itself to be a fantastic communications technology to be able to deploy sensors at scale cost effectively. I can go and put one of these on the wall and start sending data. I don't need an electrician, I don't need to run cables, I don't need to talk to the IT team to get it on the Wi-Fi network. It sits outside our enterprise network, so it provides a more secure way of getting sensor data moving around. And so we've now got 415 buildings hooked up. We've got about 850 teaching and learning spaces, so our theatres, our classrooms are all sending data, and around 2,500 sensors. The other thing we did was we also integrated with our building management system. So the building management system is a software system that will obviously run the boilers and the chillers and the various components that keep the building air conditioned. And it was a source of information. There were CO2 sensors already as part of the building management system, so we could leverage that data, as well as other data points relating to the status of a boiler or a chiller or a handling unit that then fed into the decision making around, does a space need intervention? These are some of the visualisations that we built. So this is sort of a first port of call where someone can drill in on a very specific space on the campus and be able to look at the air quality parameters for that particular space through our Campus Now application. And this is one of the other graphs that I tend to nerd out on a bit because you can see here the yellow shows the CO2 levels in that particular space, and you can see those two very marked peaks there. They'll relate to a class being held in that particular space, and as the number of people move into the space, and we all breathe and exhale CO2, up go the levels. And so this is really about keeping those levels within the thresholds that have been set with our experts on campus and making sure that the building management systems were running and keeping that air turned over. And then this is the report that goes to our campus management folk to highlight any rooms that are in need of an intervention. So again, a multidisciplinary initiative, which is a fantastic thing at a university where we're fortunate to be surrounded by people with very, very good ideas and lots of expertise. We're able to roll out a QR code and a contact tracing capability months before the Victorian government. We're able to proactively intervene in our teaching and learning spaces where air quality was going to be a problem. And we were able to provide quantitative evidence back to our students that we were taking this very seriously and that we were giving them a safe environment to come back to. Because you've got to understand, everybody has a different risk appetite, and so if you want, equity in terms of teaching and learning spaces, you want to make sure that every single person, no matter how uncomfortable or what trepidation they had about returning to university, felt as though they could come back and that the spaces were safe for them to sit and learn in. So before I move on to the open and accessible access to data, there's 2 points I want to raise from these previous cases that I've just spoken to. One is about privacy. So particularly in the estate planning where we've got the people centres, privacy always comes up as a bit of a question. So what we do in Smart Campus is we don't ingest any personally identifiable information. So the information is all anonymised before it comes into our data lake. And the sensors that I showed you have no capability whatsoever to, one, identify an individual, or two, send any video out or any imagery out from them. They are purely a quantitative sensor that sends just a number. And so we're very mindful that these types of technologies can be perceived and in some cases used incorrectly. And so privacy is also paramount for us. The other thing is that, and Jason alluded to this earlier in his talk, that whilst these data sets have an operational aspect and they have an aspect in terms of the student welfare, they do double as a fantastic resource for the university in terms of both research and teaching and learning, because the data sets could be used by a researcher who's working on a paper that requires a data set that's in our lake, or a lecturer might come to us and say, hey, this would be a really good idea for my subject, can I use this data? So by building the platform the way we have, we've made it very easy and straightforward to be able to share that data with those people, but do it in a way that's controlled, well-governed and secure. Which leads me on to open and accessible data. So as Craig said earlier in his speech, we've embraced open data standards wherever we can to maximise the utility of the data that we collect. So for our sensor data, we use the open geospatial measurement and observation and measurement model, and it has a well-defined way for describing sensor data and adding a geospatial aspect to it. It's in a neat little JSON format, so it's very easy for modern software and scripts to parse. And so, again, by using the standard, when someone comes to us and says, oh, we need the data for the temperature in this building, we're like, okay, there you go. And it's in a simple format for them to work with. For our building management system, we've elected to go with Project Haystack. So Haystack is another format that describes building management very well, and particularly around our plant assets. And again, being an open standard, our contractors that work with us have begun to migrate over. So now we've got a very easy way to exchange data with our different mechanical and electrical contractors. So yeah, open standards, it brings inclusivity and operability to the data. The LoRaWAN network that we've built, it has a dual purpose in that there's a private component that we use for all our operational work, and there is also a public component. So you could come to the University of Melbourne with your LoRaWAN temperature sensor and connect it to the Things network and begin to leverage the infrastructure that we can, that we have for whatever purpose you would like. We have open and published APIs so people can connect with our lake and bring data out. And as I said earlier, it doubles as an operational resource as well as a teaching and learning resource. So how did we build it? What did we do? This is our tech stack. So we use around 9 key products from AWS and then a handful of other small products. So data producers on the left through to data consumers on the right. We have our sensor network and acquisition where we acquire the data. We have our APIs endpoints in there as well. And then we use IoT Core for a lot of the sensor data and some of our integrations. And then we use Boomi as our integration platform, enterprise integration platform. We have a number of ETL pipelines that we've built, predominantly using AWS Lambda, and then our lake is built on S3, and then our warm storage on DynamoDB. Then our analytics, we have Athena, which allows us to expose the data in the data lake via SQL queries. We also have a number of Python libraries that we leverage, and we've just begun to use SageMaker as well, AWS SageMaker for some modelling. Visualization, as we spoke to, Splunk. Our campus now application is delivered on React using Node, and we are also now beginning to use QuickSight more and more as that intelligence tool. If we drop it down a level, so this is sort of a high-level architecture of what we've built. We've got the producers there on the left. We've got our ingestion layer, which we've spoken to, and then we've got our processing stream. So we have a number of data processing streams that will extract the data from the payloads, perform whatever transformations required, and then load them into the requisite store. So we have an occupancy pipeline, for example, that takes all that occupancy data from our sensors and does a lot of magic to it. We have a building management pipeline that takes all the data from our building management system and again performs a number of derivations of different statistics and then pushes it through the lake. The lake's shown there in the top right. So we have, as I said, built on S3. We use Parquet as the format that we store all our data in. It's I guess, an optimized form of JSON, and it's very well suited to use with AWS Athena in being able to expose data that's stored in S3 buckets via a standard SQL query. So that's the main way in which we expose some of the data is through Athena to things like QuickSight and so forth. The other mechanism that we have is the warm storage, which is based on DynamoDB. So we move some of the data down there, and then we're able to expose that via API gateways that we've built. And again, that's where we're able to provide a very granular way of providing data to different people based on their requirements. So it's used by our Campus Now application, but also by university researchers and third parties. And this is just an example pipeline. This is part of the building management pipeline. So you can see there, we ingest data from our LoRa sensors. We've got data coming in from our building management system. We also bring in data from the Australian Bureau of Meteorology, which provides weather information to the country and allows us to do some of the forecasting and modelling that we do. So in closing, we're in year 4, and I'm very lucky to have been brought on board to help move this piece of infrastructure from a capital project into a productionised service, which is in recognition by the university that it has a place ongoing in the institution. And so, but as part of the journey, these are the things that I think are probably most important, is that, take the time up front, and Jason did speak to this, about developing your observation and your data models before you sort of entertain different use cases. Get your data model right, and get your governance right as well. When you've got a lake with lots and lots of data in it, and you've got lots and lots of people coming in saying, I need this and I need that, if you don't have good governance, it's going to be very, very difficult for you to manage. The other thing is, how does it work at scale, right? So if you think I've got 12 sensors on the wall over there, that's right. But how do I manage 2,500? They run on batteries. How am I going to change the batteries in those sensors? How am I going to maintain if one goes offline? How am I going to set up the processes that someone says, oh, the temperature's not right in my room, looking at the chart, how do they log a ticket? There's all these things that you have to keep in mind that when you want to build this at scale, that you need to solve. And then the last one is to limit the sprawl of your IoT devices. Like, it's very tempting, particularly for a nerd like myself, to get out there and just try every sensor under the sun and throw them out into production and just go for it. But it becomes very problematic to maintain a very diverse fleet of sensors. So by all means, try all the sensors and put them through their paces, but try and settle on a small cohort that actually go into production. So with that, that's all from me, and I'm going to pass back to Craig, who's going to finish up. No worries.
I think it's really interesting to see what they've built with a really small team. I think it's about 7 people over 4 years. And if you think about these properties, they're worth hundreds of millions, billions of dollars. Think about the value that they've extracted from this platform for 150 different nations the countries come from, the students come from. Just quickly, another interesting use case. I'm just going to fly through. There's a transport agency in Australia, and somebody there realised that their elderly mother didn't have access to transport information, so they came up with this idea of a smart bus shelter. And it was built one of our partners again, Sage Automation. And when they were looking at this smart bus shelter, they put it in near a hospital, because often people near hospitals are elderly or disabled and need access to information, and sometimes they need to be able to get transported home as well. So they designed this interesting, innovative bus shelter with a touch screen and solar panel, so it was highly sustainable. And on those displays, they showed the timetable, they showed alerts, so if people were going to miss a bus stop that, or bus was going to go past, they could see that if there were any service alerts and that type of thing. And the good thing about a partner like Sage in this instance is they're very good at building purpose-built for the right Australian environment, IoT and sensor equipment that can last for a long period of time. So you can see here some of the elements they put into the environment. And so from this, they can tell some really interesting data. They can see the passengers on that top graph. They can see how passenger usage is running over time. They can see how that runs with weather. They can see the battery stats, because the solar panel actually charged batteries, which are actually sitting under the seat in the bus shelter, which was a pretty cool innovation. And at a high level, this architecture was, if you can see the bus shelter there on the bottom left, they had their own Sage Edge platform, so they created something a platform again that they could extend on. That then took the data that was around the passengers and whether there was a bus there and sent that up to our IoT core service. That then routed it to the back end. But also they had the bus back end on the locations and the schedule that could send the information back down via the same Edge product to the screens of the bus shelter. And the interesting innovation here is the use of Amazon Poly. So if you had visually impaired passengers, they could basically turn the bus timetable into audio so that they could understand what was coming next. And I wanted to call this out specifically, this solution, because Casey Hames was a winner of what's known as the Holman Prize, which is an international award recognising innovative thinkers, and she extended on this bus shelter solution with the See Me app, which was an app which bridges the disconnect between bus drivers and passengers. Often that can lead to passengers being left behind. The app notifies bus drivers when there's a See Me user is waiting at an upcoming stop, and also it alerts the user on the bus when they're coming up to their destination. So this was a great innovation out of Sage, and looking at how they can extend the bus shelter concept. I had some other ideas too. The assistance button. I like the LED one at the bottom. You can see the green LED lights. Using LED lights to indicate how far away the next bus is. I think that's a really interesting innovation. And also using some detection there to understand if there's a disabled passenger that might need assistance in getting on and off of the vehicle. So another interesting little solution. There's a sister presentation in IoT. The code is IoT301, and it's on tomorrow at 11:30. It's about a very similar topic, but it's a focus on sustainability. So if you'd like to learn more about what Amazon's doing with smart buildings and sustainable buildings, I suggest you do yourself a favour and get along to that one. And if you're looking for a smart city solution, remember the competency I mentioned up front. This allows you to look up solutions that we've vetted and made sure that they're fit for purpose and of a high quality. I'd like to thank some of the partners. This is just a small selection, but these are the partners that were involved in the solutions you've seen today. And if you'd like to learn more about smart cities and AWS, there's a QR code that will take you to a landing page. It's worth considering that the world's population is increasingly becoming more urban, and as technologists, it's really on us to consider how we can make these cities more inclusive and accessible. So if you could put together your hands and thank the University of Melbourne for coming across today to talk about the campus, that would be wonderful, and fill in the survey afterwards as well. Thank you very much.